Hi everybody. Today we're going to be using what we learned about determinants of a matrix in order to find the equation of a line. One thing that we haven't talked about was what a determinant actually represents graphically. So I just want to take a minute and talk about that. The determinant of a matrix actually has to do with the area of a triangle that's formed from the origin to two other points on the coordinate plane. So when you're finding the determinant and you're doing those cross products, what you're actually doing is finding the area of a triangle formed by the origin and two other points on that coordinate plane. Now, so that would look kind of like this. If we knew that we had 2 points on the coordinate plane, then if we took the determinant of that and then we cut the determinant in half, what we would actually find is the area of the triangle formed by those two things. So we can use that to our advantage if we know maybe that the points are on the same line. So if they're on the same line, then they actually don't form a triangle, right? They don't form a triangle, and so therefore the determinant would actually be 0 because the area of a non-existent triangle is 0. Now, we can use that to our advantage. If we think about a general matrix that kind of looks like this, right? So if we know 2 points are on that line, then the coordinates of those points could go in our matrix x sub 1, y sub 1, and x sub 2, and y sub 2. What we would need to use, though, is a generic xy as a potential third point that would also be on that line. But, this isn't a square matrix. So remember that we can't find the determinant of matrices that aren't square matrices. That means we need to add something to this matrix in order to make it a square matrix. And what we do is we add 1s down in that third column. And because we're assuming that these points are on the same line, we set the determinant of this matrix equal to 0. Now, we can use this to help us find the equation of a line if we know the coordinates of 2 points that are already on the line. So let's assume for a second that we know that the point 3, 2 and 5, 1 are on the same line. Now, if they're on the same line, then we can put it in our square matrix that looks something like this. So we have our generic x, y, and 1. And then we're going to put in the coordinates of our first point, 3, 2, and the coordinates of our second point, 5, 1. And now don't forget we also need the 1, 1, right? That third column, that's equal to 1. And we know that that determinant is equal to 0. Now, you can use Laplace here, or you can use Saros. It doesn't matter. I think what I'm going to do is I'm going to use Laplace this time. If you remember correctly, using Laplace, it looks kind of like this. We take x times the determinant of the 2 by 2 matrix that you have when you cross out the row and the column that x is in, and then minus, and we're going to go across the row, minus y times the determinant of the matrix 3, 1, 5, 1. And then we have plus 1 times the matrix, the determinant of the matrix, 3, 2, 5, 1. Now, finding the determinant and combining it all together, we know that this determinant is equal to 0. So I'm going to go ahead and use what I know about finding the determinant in order to simplify this expression. So finding the determinant of the first matrix and multiplying it by x, we get 2 minus 1, which is 1, times x, which is x. Going down the line, we get 3 minus 5, which is negative 2, and negative y times negative 2 is plus 2y. And then down the line again, 3 minus 10, we get negative 7 times 1, which is negative 7. And we know that this is equal to 0. Putting it in standard form, we get x plus 2y equals 7. So x plus 2y equals 7 would be the equation of the line that contains the points 3, 2, 5, 1.